Okay, so today's assignment, kind of this differentiating between distance and displacement. Okay, how far is the total distance traveled? Always a positive number, even if we change direction. Total distance traveled divided by the total time is going to give us our average speed, which is s. Our change in position, delta x, which is displacement is delta x, is your final position minus initial position. All right, your difference between starting and end point. Now you can have a negative number. And now to find average velocity, you're going to take displacement over time. So in this first one, I'm just going to kind of run through this a little quickly. We started at 2. We went up to 4. So we moved 2 meters. Flatlining here, we were at position of 4 meters. We didn't increase or decrease, so we didn't move. And then this last segment here, we went from 4 to 8. So that's a distance changed here of 4 meters. So 2 plus 4 is 6, average speed equation, total distance over time, boom. Now displacement, final position. So where do I go? At the end of the time, I go to the final position, which is right there. And if I go across, that's at 8. So final position is 8. Our initial position would be at the start of this, which would be at 0 seconds, and that is at 2. 8 minus 2 is positive 6. Over the whole time of 16, and you're going to get a positive value here. In this one, we started off by not moving, and we're at 5 meters, right, above where we should be starting. And we go from 5 down to right here, and if we go across, that's to 1. So we moved the total distance there of 4 meters. And then this last couple seconds here, we're not moving again. So the total distance traveled is only 4 meters. Average speed, total distance over the total time, 0.5. Now displacement, final position, which would be right there, and go across, that's at 1. So xf, final position is 1. And our initial position is at time 0 here of 5. Boom, negative 4 meters. And displacement divided by time is how you find velocity. Negative 4 over 8, and you get a negative 0.5. Okay, here, this would be, this is negative 10 meters. Sorry, got chopped off. And then it says, assume that all trips take 10 seconds worth of time. All right, so first one, super quick, super simple. You start at 0 and you walk to positive 10. How far did you just move? 10 meters. So average speed, all right, if we don't remember what that is, distance over time. So we moved 10 meters in 10 seconds. 10 over 10 is 1 meters per second. Displacement, delta x, that equals final position minus your initial position. And then average velocity would be v is equal to delta x over t, which is your displacement divided by time, which if we needed to as well, final minus initial position over how long you move for. Okay, well here, same thing. You started at 0, we moved to a positive 10. So if our final position is 10, our initial position is 0, our displacement is equal to positive 10 meters. And average velocity is delta x divided by the time. Again, it's saying all trips take 10 seconds, so plus 10, positive 10 meters over 10 seconds, plus 1 meters per second. All right, that one, Ms. Lombardo, super easy. You're not wrong. All right, but let's take a look at something that's a little bit different. How about number 4? So number 4 is saying we're going to start here at negative 3 meters. Right there. Now, what does it tell me I do? Starts at negative 3 and then walks to where? Positive 3. So 1, 2, 3, 4, 5, 6. This is positive 3. And then what else? And then it says goes back to 0 and stop. Okay. So how far did I move in total? So we count. 1, 2, 3, 4, 5, 6. So we moved 6 meters that way, and then we went backwards. 1, 2, 3. 6 plus 3 is how much? Okay, so we went 9 meters of distance. Average speed is distance over time, so our 9 meters over 10 seconds, which would be 0.9 meters per second. But what about our displacement? So we started here at this yellow dot, -3, and we finished here at the red X. Okay, so we need to figure out what the displacement is. So let me ask this, guys. What is our final position? We stopped right there, right at 0. So my final position is 0 minus, what was our initial position? -3. And when you do 0 minus a -3, all right, for delta x, that is equal to a positive 3 meters. Okay, and then average velocity is your delta x, which you got in this column here, divided by the time. So you're just going to do positive 3 over 10, positive 3 meters over 10 seconds, so a positive 0.3 meters per second. Let's do one more. You get to pick the number. 6. All right, let's take a look at 6. Okay, we're going to start at -2 and then walk to positive 4 meters. So we're going 1, 2, 3, 4, 5, 6, and then stop, right, or then turn around and walk back to -1. So that was 6, right? 7, 8, 9, 10, 11. Okay, so we moved a total then of 11 meters. Distance over time be 1.1 meters per second. But what about our displacement? Okay. So guys, where did we finish? We finished right here at this red X, which is -1. So that's my final position. And what is my initial position? Minus a -2. All right, so if you needed to, you can toss it into the calculator. -1 minus -2. And we get a value here of +1. And then in the calculator, all right, or the equation, delta x over time, +1 over the 10 seconds, positive 0.1 meters per second. Okay, you guys need to finish 2, 3, 5 for homework, which you guys have some time right now. You guys may be actually able to finish it right off the rip, okay? If you guys have any other questions, please let me know.